So last class we discussed about drag and lift. We will be discussing in continuation of that. Yesterday we discussed about lift. Okay. So today we'll be seeing what are the parameters in the lift. Okay. As you can see, you can compare SUV and passenger car. Main classification related to ground clearance. That is how the ground clearance is going to influence the lift. I think you are able to see the PPT. You can see in first sketch, it is a SUV, okay, where ground clearance is more. And you can see in the second sketch, we are having what? Passenger car, okay. So you can see when there is a large ground clearance, what happens? Okay, you can see the air speed, no? There will be a small increase. So the pressure will be reduced, okay. So in the over the roof, you can see there will be the small reduction in air speed, okay, compared with this one passenger car. Okay, so you compare this flow that is for a SUV as well as for a passenger car. You compare this, so you can see you will be having the force from the bottom will be less when I'm having a large ground clearance. That is, you can see there will be a negative lift force, whereas for passenger cars you can have positive lift force. Okay, so due to this flow pattern. So you please make a note. That is refer the sketch and please understand the difference between the ground clearance of a passenger car and SUV. Okay, that is you can see that is the first car we are having what negative lift force. Okay, so what happens in this the contact with the ground wheels will be maintained. Okay, whereas the positive lift force, the road holding capability will get reduced. Okay, so you can see what happens here. You are having a venturi. What do you mean by venturi? Means the airflow will get increased. That is, velocity will increased and pressure will get decreased. That will be termed as venturi. Okay, so you can see compared to a passenger car and SUV, you'll be having a venturi effect here. But on comparison, you can see here the area is more. Okay, so more there will be airspeed increase will be less. Okay, whereas here the air flow will be slow and we'll be having what high pressure. The high lift, positive lift will be there. So we will see what happens now. So for any car, you can see the underfloor space will be becoming a venturi compared to the roof. We are having what a constructed area. Okay, so what will happen? The air will flow much faster underneath that is under the body than over it. That is when you are comparing over the roof and under the body, we can say Under the body the air will be traveling at high speed, because we can say it is a venturi effect will be there for any car, comparing the roof and underbody. Okay, so you can see this airflow pressure will be higher than for underfloor body. Okay, so here for a venturi effect, what will happen, the velocity will be increased, so pressure will be decreased compared to the top. Okay, so there will be a net downward force. You can see here in the SUVs you can have a net downward force, that is it will be increasing the contact pressure between the wheel and ground. Okay, and you can see in second sketch will be having a positive lift, that is you can see the force will be acting upwards. Then we'll be discussing about aerofoil lift and drag. So this sketch will be giving more indication about this. Let me highlight the sketch. So you can see the sketch. There is a. It will be explaining the aerodynamic lift versus ground. Okay, the aerodynamic lift versus ground floor height. You can see a passenger car. Can see a passenger car. You're having a Venturi, so here the airflow will speed will be getting increased, and you can see the lift coefficient. How far the lift coefficient will be increasing over this dimension. Okay, so here at the starting, okay, at the starting, you can see the lift coefficient will be more, and gradually, that is you can see this one is a car height range. Okay, that is you will be having a positive lift in this region. Positive lift, that is the force will be acting upwards. There is a more pressure will be at the down. So what happens? The force will be acting upwards. That is up to this region. Okay. When you are going to enter into the Venturi effect, what will happen? Here the airspeed will be increased and the force will be decreased. So you will be having what? Negative lift. So you have to understand that is before this area, that is before this Venturi effect, what will happen? The force will be more. That is we'll be having what? The lift coefficient is more, and we'll be having a positive lift. Okay, so it, the tendency to lift the car will be more. That is before this. When after Venturi, you can see the airflow speed will be increased, so the pressure will get decreased, whereas at top the pressure will be more. So we'll be having what? Downward thrust. So you can see the lift coefficient will be decreased when it's going to getting into the Venturi effect. So you can see it is gradually it will be decreasing. After a particular instant, you can see the lift coefficient is going to get increased, because it is going to move towards what? The larger ground clearance. Okay, so again it will be increasing. So you have to understand this variation. This variation explains how this aerodynamic lift is going to vary with ground floor height. Okay, how it is going to vary with ground floor height. Next, we'll be seeing this is important, lift and drag. Yeah, this is important. Next sketch I am going to show both lift and drag. Okay. Yeah, you can see here we're having what? Both lift and drag. Carefully observe the sketch. So you can see a flat plate. Okay, so see the sketch. You are having a flat plate that is somewhat inclined, and you can see the direction of airflow. Okay, so the air is going to flow in this direction. I am placing a flat plate. So based on this, what will happen? Under this plate, the high pressure will be active, and over the plate, a low pressure will be active. So the net force will be what? Upward force. That is in a vertical direction, the net force will be upward. And if you are going to consider in a horizontal direction, what will happen? It will be the backward force. That is a drag. Okay, so that is a drag. So we are going to find out the total reaction force. That is the lift force is upwards, drag force is horizontal, that is acting towards the right, and this one is towards up. So this one is what? Total reaction. That is when I'm going to combine both lift and drag, that is the aerodynamic resistance force, it will be what? Total reaction. And the angle made with the vertical component, we can say as theta. Okay, and this angle, the angle made by the plate with the horizontal, we can say angle of attack. Okay, so we can summarize everything and we can write this force diagram. That is what will happen. Larger lift component and smaller drag component. Okay, so this one you have to understand. That is when I am going to keep like this. The main thing is you have to understand. Compared to drag, my lift will be more. So the force diagram, the magnitude of the force will represent this line length. So we'll be having what? Larger lift length, and here you'll be having what? The small drag component. Okay, the drag force will be less compared to the lift force. Okay, so when this angle is going to get increased, you can see this is the main thing and the objective you have to focus. For small angle of inclination, lift will be more, and you can see where the larger angle of inclination, the drag will be more, lift will be less. That's all. This is the main thing in objective. Okay, so due to the pressure variation, so when larger this one, what will happen? The lift component will be getting reduced. So because more frontal area, the logic is more frontal area. Here see the frontal area is less, whereas I am going to have a large angle. Frontal area is more, so more amount of force will be coming in horizontal direction. Small amount of force only in vertical direction. Okay, so you have to understand. You please make a note. For small angle of inclination, lift will be predominant, whereas a larger angle of inclination, drag will be predominant. Okay, so you please remember this, and you can see the first sketch. What happens? Pressure under the plate, that is a normal inclination, that is you can say as a small angle. Pressure under the plate will be more, above it be less. Okay, so you have to remember the greater angle of inclination, smaller will be the upward lift component. Okay, so whenever we are having a flat plate similar to this fashion, I'm going to keep it in the airflow. When the angle is going to be more, actually we'll be having a positive lift only, but what happened? The magnitude will get decreased when I'm going to increase this angle of inclination. Okay, so you please remember this: angle increases, drag increases; angle decreases, drag decreases; and angle less, lift will be more, and angle more, drag lift will be less. So from this we can frame a objective. Okay, so this one is a flat plate, and you can consider the next one. Yeah, aerofoil plate. Okay, you can see aerofoil plate. That is, we are going to compare the airflow pattern with flat plate and aerofoil. You can see we are comparing the airflow pattern with a flat plate and aerofoil. So you can see the direction of airflow. So it is a flat plate. So over the plate, you can see vortices. So the pressure differences will be there. Here also we are having what? Vortices. Whereas here you can see the flow is more or less streamlined. flow separation is not taking place. Okay, so vortices will be almost nil. Okay, so you can see it is a smooth flow. There is no separation is going to take place, and we'll be having what happened in the upper. The air speed will be increased, lower pressure, whereas here the air speed will be decreased, higher pressure. Okay, so you can see in aeroplanes you'll be having this profile so that I can produce what lift. Okay, so aerofoil pattern is adapted for aeroplanes. So I need more lift. But for automobiles, we doesn't need a lift. We need what? Negative lift. That is, it should retain the contact with the ground. Okay. So you can see, observe this. So you have to remember CL, C suffix L is coefficient of lift, and C suffix D is what? Coefficient of drag. And angle of attack is what? The angle in which the airflow is going to get impinging on the plate. You can see that is in the last sketch I have shown you this theta. This theta is known as angle of attack. Wait for a minute. I will put the another sketch for you. Yeah, this sketch is very important to understand the variation of lift coefficient and drag. Okay, so you have to understand this. See, can see this angle of attack. Angle of attack is angle in which the flat plate is exposed to the airflow. Okay, so whenever the angle is going to get increased, you can see the lift will be increased, and further increase will not produce any lift increase. It will be decrease. Okay, so you can see the lift coefficient, and here you can see the drag coefficient, how it corresponds to the angle of attack. Okay, that is, you can see at smaller angle of attack, you can see smaller angle of attack, lift will be more, drag will be less. At larger angle of attack, see already I've told explained, larger angle of attack, say 16 or 17, lift will get decreased and drag will be more. Okay, so you remember this variation. The sketch explains the variation of lift and drag with angle of attack. Then now we'll be discussing about the nose. Let me put the sketch. There are two different types of nose: downward turned nose profile, center turned nose profile, and upturned. Let me put the sketch. So just you can see the sketch and you can get the idea about the airflow pattern. Okay. I think you are able to see this. See, I'm having three types of nose. There is one is a downturned nose. You can see it is a downturn, and another one is a central nose profile, and this one is upturned nose profile. Okay, so how it is going to influence? So if I'm having a downturned nose, no, the airflow, the amount of airflow which is going to flow under the floor, it will be less. Okay, that is, you can see the mass airflow under the floor will be less. Whereas here, the mass flow rate of air over the roof will be more. Okay, and you can see the diagonal flow also will be less, and vortices will be also less. Okay, so this is the pattern when I'm having a downturned nose profile. When I'm having a central nose profile, what will happen? Here it is lower, no? So just it will be increasing. As you can see, the amount of airflow will be increasing, so that more or less the airflow will be more or less it will be same. Okay, so you can see the variation. So the vortices will be starting to form. Here the vortices will be less. That is a small vortices will be there. Here the airflow is getting increased. We'll be having what? Medium vortices. And the last one is highly critical. That is when you are going for upturned notes. What will happen? The airflow will be maximum. The mass flow rate of air will be maximum under the floor. So what will happen? The vortices will be more, and you can see compared to the roof, you will be having what? More airflow under the floor. Okay, so it results what? More vortices in the rear. Okay, so this is going to explain what are the different nose profile and how it is going to influence the airflow pattern. Okay, so you have to remember which nose configuration is desirable. That is the main thing you have to remember. That is when you are designing the car, where to keep this nose. That is a stagnation point, because the airflow will come, it will hit this nose, and it will get diverted. Part of air will be going upwards, and part of air will be going downwards. Okay. So while aligning this nose properly, I can optimize my drag coefficient and lift coefficient. The influence will be more on lift, you can see, because compared to drag, this will influence more on lift. Okay. So let me give that parameter. That is, you can see, already I told you, in a down turned nose, what happened? You can see the sketch. The largest portion of the air, okay, is going over the body. Only small is going under the body, and central nose is more or less same, and upward nose, more air is going to flow under the body. Okay, so you can see where the vortices will be more and what will be the drawbacks. So another one important thing what you have to understand, no? When the air is going to flow under the floor, there will be interaction with that mechanical component. That is, in the airflow, there will be some resistance. Okay, we'll be having that underfloor components. No, so we'll be having viscous interference. There's the appropriate word is viscous interference. Okay, so that will be more when more amount of air is going to flow under the floor. Okay. So that only you are having this diagonal flow. Actually, when the air is going to flow over the roof and the air is going to flow under the floor, the diagonal flow will not be happening. When it is going to happen, no, that is when I am having the viscous interference. That is when I am going to obstruct the air flow. What will happen? The air will be flowing in the diagonally. Okay, so the air will be flowing diagonally. So whenever I am going to increase the mass airflow, that is when I am going for upward nose, more air will be flowing under the body, and you can see in the sketch what happens. More amount of air is going to flow diagonally. Okay. So what will happen? Vortices will be there. That is in side vortices also will be there, and trailing, that is at the rear end also, it will be having the vortices. Okay. So this is the main thing you have to remember. There's an upturned nose, no, the drag coefficient will be 0.24. Okay. and central and downward nodes you will be having 0.223 and 0.224. You remember this? I am putting in the slide. So for upturned nodes, what will happen? That is that they have done this test in the wind tunnel and they have observed this. Okay, let me put it in the slide so that you'll be able to know the value. So under wind tunnel, they have found out that when we are having upturned nose, okay, we can see the drag coefficient is about 0.24, and downturned and central, you can see the difference is somewhat less, 0.001. Central we are having 0.223 and downturned we are having 0.224. Okay, so it is getting increased. For drag coefficient, not that much influence with this nose profile. Already I told you, know, only for lift it will be influencing more. Now see, same thing I'm going to compare with the lift. Let me put it in the next slide. So you can see the nose profile is going to influence the lift more. Okay, see here, lift coefficient when I'm having a upturned nose. Okay, so what happens? See, zero point 0.2 plus zero point 0.2, it is increasing my lift. There's a positive lift. It will increase the it will decrease the reaction between the road wheels and the ground. Road holding ability will get reduced. Okay, and the central nose profile we are having a positive, but see the value is about 0.02. Okay, will be having a positive. There is a positive lift. The force will be acting upwards. Whereas downturned nose profile, no, it is very, very desirable for me. It is having what? Negative. That is, we'll be having a negative lift so that the tire will maintain contact with the ground. So for a lift purpose, the nose plays an important role. Whereas a drag, the influence is very, very less. Okay, that is in 0.001 or 0.1. Okay, so the lift is going to be getting affected when I'm going to choose the proper nose profile, either downturned nose or central nose or upturned nose. Okay, so this will give a significant information how the nose is going to affect drag and the lift, and the conclusion is it will be affecting the drag marginally. That is, you can see here 0.24, 0.22 and 0.22, just 0.02 only the difference between all the three. Okay, whereas in the lift the maximum difference is going to come. Okay, so note down this value so that you can magnify the effect. In terms of value, you can give the explanation. Okay, next we are going to discuss about what are the optimization techniques to reduce the drag. That is, what is the design I have to do in car body for reducing the drag. Okay, so we will start this. This is very, very important. Optimization techniques are how to design to reduce the drag. First of all, we will see profile edge rounding or chamfering. Profile edge rounding or chamfering. Okay, let me put the sketch. Yeah, see, we are having a very good sketch. First of all, we will see the sketch and understand. Then I'll be giving some other points also for objective questions. Okay. think you are able to see this. Yeah, this is you can see the car body. We are having a windscreen, bonnet, and we are having a nose. So what we are going to discuss is a profile edge rounding or chamfering. Okay, so this section we are going to discuss about this section, profile and how I am going to add. So first one you can see I am going to have what, rounded one. So it is going to come and it's going to have a rounded one. And second one you can see it is a chamfer. Instead of having a rounder, I'm going to have chamfer. Okay, and you can see the optimum thing. Instead of having a flat one like this, it should be going like this. Instead of having a rounded portion at the ear, the front portion itself, I'm going for a rounded one. This one is what? Optimum nose. Okay, optimum nose. So for this, I'm going to compare the drag coefficient. You can see for rounded, the drag coefficient starts from a 0.3. There is on increasing the radius, what will happen? On increasing the radius, there is a more smoothness we are going to have. There is the airflow will remain attached. So increase the radius, you can see the drag coefficient is going to get decreased, whether it is rounded or chamfered. But for chamfered, you can see we are having what? Significant reduction in drag coefficient compared to rounded. Okay, that is for a particular radius. Say for 20, you can see for rounded it will be 0.41. It will be less than marginally compared to the rounded. Okay, so this sketch explains what is the influence of the wood angle. The you have to understand this shape, no, the wood angle, that is a bonnet angle on drag coefficient. So this one is known as profile edge rounding or chamfering, whether you have to go for rounding or chamfering. Okay. So you have to understand that is whenever I am going to increase my radius, that is when I am going to have a rounded corner or whether I am going to have a chamfer. When I am going to increase the radius, what will happen? I can decrease both the lift as well as drag coefficient. Okay, so you can see in the sketch the drag coefficient is initially 0.43. When I'm increasing the radius, either it is a rounded or a chamfer, you can see it is decreasing to about 0.4. That is the main inference you have to get. See, initially 0.43. When I'm going to have a rounded corner, otherwise I'm going to have a chamfered corner, the drag coefficient is going to get decreased when I'm going for a rounded. So when I'm increasing the radius, you can see from 0.43 to zero point 0.4, it's going to come. Okay, and for chamfering also the same phenomena. Okay, so you have to remember this. Okay, and the radius is how much? 0 to 40. So the final conclusion is when you are going for a chamfer or when you are going for a rounded corner, when you are going to increase the radius for a particular range, say 0 to 40 mm, the drag coefficient can reduced from 0.43 to zero point 0.4. Okay, so we can achieve a reduction 0.03. So that is a main thing, and you can make a conclusion that compared to rounding, chamfering will have some greater reduction. And in the curve shows that after 40 mm, there is no significant difference between rounded or chamfer. That also you have to remember. Okay, so that is a main thing. That is if your radius is less 20 mm, you can go for chamfer. You will be having the drag coefficient less. If the radius is 40, either rounded or chamfer doesn't have any significance. Okay, so you note down this sketch. So this comes under profile edge rounding or chamfering. Next, we will be discussing bonnet slope and windscreen rack. Let me take the sketch. I'll be sharing this PPT with you, not an issue. Okay. After completing the class. See in the sketch, I am going to explain you. Bonnet slope and windscreen rack. The bonnet slope and windscreen lap. So what is the angle of bonnet? When I'm going to say bonnet slope means how it is measured. You refer the sketch how it is measured. See from the lower windscreen, you are drawing one horizontal line, and this slope, the angle made by the horizontal with the bonnet is known as bonnet slope. The other word is wood. Okay, so in first class itself, you might have studied there are two words for bonnet. One is wood, and another one is conventional word bonnet. Okay, and similarly, windscreen rack angle. That is vertical. For this, we are taking horizontal. This one is what vertical. Okay, so you take this the same angle inclination of the windscreen and extend this and measure it with the vertical. You'll be having what windscreen rack angle. So you can see in the sketch bonnet slope when it is getting increased, what will happen? The rack coefficient is going to get decreased. Okay, so you can see they have tested in a wind tunnel and they have observed this. When I'm increasing the bonnet slope, the rack coefficient is getting decreased because that is what we are having more streamlined. When I am decreasing the bonnet slope, that is I am making it somewhat less streamlined. I am allowing for airflow separation. Okay, and this also you can see when I'm going for the windscreen rack angle. When I'm going to increase, you can see the rack coefficient will decrease. When I'm going to decrease, no, what will happen? It will be more vertical. When I'm going to increase only, it will be inclined so that the airflow will remain attached to the windscreen. Okay. So when I'm going to decrease, it will be more vertical and it will be increasing the frontal area. So it increases the aerodynamic drag. Okay. So you have to study this influence. You don't need to remember the value. Just you have to understand when bone slope angle is getting increased, my drag coefficient will be decreased, and the windscreen rack angle is going to get increased, my drag coefficient will be decreased. So this two thing you have to remember. Okay, and the reason is very important. Okay, that is you can the reason is very important. When I'm going to say it is decreasing, why it is decreasing, that also you have to know. Okay, so in the sketch you can see that is I am increasing the bonnet slope angle. That is I can't go for a max a limit whether it will be practically not possible. I will be having a flexibility to increase this angle to a particular limit only. So from you can see from 0 to 10 degree. From 0 means it will be the bonnet will be more horizontal. Okay, so from 0 to 10 degree I can increase my bonnet, that is a slope angle. Then what happened? The drag coefficient will be decrease. I can't go beyond 10. Okay. Then what will be the happening? No, when I'm going beyond 10, there will be no influence on my drag coefficient. Okay. So you can see after 10, I can't say any influence on drag coefficient. Okay. So this is the major role. That is, I am streamlining. After that, I am not doing any work to improve my aerodynamics. I can't go beyond 10. Okay. And similarly, the rack angle, it may be starting from vertical and it will be going to inclined. Okay, so the rack angle I can increase. Okay, so if I'm going for a larger rack angle, no, the body styling will be the major problem. Okay, that is, I can't increase this rack angle to a greater extent. Up to a particular limit only I can have. That is, I can't have a rack angle. You imagine, I can't have a rack angle a 90 degree. 90 degree means the windscreen will not be inclined. It will be like a flat. Okay, so there is a practical difficulty is there, and I can keep further large also, so that it will the styling will be very affected. The styling will be affected when I'm going for large rack angle. It doesn't look like a car, and it will be looking awkward also. So considering aerodynamics, and I have to consider the factor in styling also. There is having a rack angle, so that I will be satisfying both aerodynamics and styling will be the most appropriate design. Okay, so you have to understand what will be the problem in increasing the rack angle beyond a limit, and what will be the problem when increasing the slope angle of the bonnet beyond a limit. Next, the last topic we will study about roof and side panel campering. Okay, just everything sketch only, you can understand easily. So you can see the roof camper, the effect of roof camper on drag coefficient. Because in the roof, if I'm going to have a profile, so that the airflow will remain attached. Okay, so when I'm going to provide a camper, what will happen? Okay, so you can see that this is the length of the roof, and this one is the camper height. Okay, so you can see the roof camper defines the ratio between H and L. How far I am going to provide the camper, that's the slope. H, whether I am going for a pure horizontal, otherwise I am going to have a slopey one. Okay, so this denotes what? H by L. When H by L is equal to 1, what happens? Okay, so similarly we are going to have this comparison with drag coefficient. So the initial value, you can see the H by H by L, you can see is 0.01. What happened? It's going to get increased. My drag coefficient will be, that is, I'm not saying a drag coefficient, the change in drag coefficient. Okay, the change in drag coefficient will be decreased. Okay, so it is going in a negative direction. Then after that, it is getting increased. Okay, that is beyond 0.6, it is getting increased. Okay, and similarly, the body side panel campering, you can see I'm using the term X by L. So when I'm going to increase, the change in drag coefficient is going to get decreased. Okay, so you have to remember the y-axis, it is not a drag coefficient, change in drag coefficient. Okay, so campering means you can see in the sketch. There is in the roof also I can do a campering, and side panels also I can do the campering. So whenever I am going to do the campering, what happens? It reduces the drag coefficient. Okay, so in the curve you can see that is when I'm increasing the campering, it is a negative value. Okay, so the change in the drag coefficient, you can see it is getting decreased. Okay, so it means what? The drag coefficient is getting changed, and it is changing in the negative direction. That is the indication of this curve. Change in the drag coefficient. Okay, change in the drag coefficient means drag coefficient is getting changed. When I'm changing the roof camber, drag coefficient is getting changed. Whether it's getting increased or decreased, you can see the coefficient value negative, no. So it is desirable for me. When I'm increasing, there is a change in drag coefficient and it is going in negative direction, so it is getting decreased. Okay, so like this you have to correlate. Okay, then after that you can see the change in drag coefficient is getting increased here beyond this, because the drag coefficient is getting increased, then the drag is getting a more. Okay, so you have to fix the roof camber for the optimum value. Okay, so you can see in the curve, I can't go for a high value for a roof camber because the drag coefficient is again is going to increase. And side panel campering, you can see there will be a reduction in drag coefficient. Okay, and the reduction is very very marginal. You can see it is 0.01 and zero point 0.2, not very much significant effect we are getting. Only a slight reduction is we are getting. Okay, and this one is a major constraint is when you are doing this campering, no, that is you should not that is you should not make a compromise in increasing the frontal area. That is when you are increasing this camper, now what will happen, frontal area will be projecting the frontal part of the car in a wall. Okay, so what happens when you are increasing the camper, you should ensure that the frontal area should not get increased. Okay, the frontal area is going to get increased, what will happen, there will be no effect in reducing the drag. In camper the drag will be reduced to say 0.01, whereas in frontal area the drag coefficient will not change, but the drag force will get changed, because the drag force influence what, drag coefficient multiplied by your frontal area and speed of the car square. Okay, so coefficient will not change, but the frontal area will increase. So what we have to ensure is when you are providing the camper, ensure that the frontal area is not getting increased. Okay, so the remaining things we will be seeing in the next class. So you please be in touch with this course, and in aerodynamics the possible objective question you prepare answer. Okay, if you're having any doubt you can ask. Any doubt?